All right, so for this lecture, we're going to talk about populations. All right, so we're going to talk about the difference between population size and population density, and then what happens when you have dense population, what are some of the factors that can affect the growth of the population, and talk about the concept of carrying capacity, which is very important. So first off, we need to define what a population is. So a population, we say, is a group of individuals that are all of the same species, and they typically are living in a very specific area at the same time, right? You all have to be together in the same area at the same time. So they interact with one another, and they're interacting with their environment, but the key point here is that they are all of the same species and they're in a certain area. So populations can vary in size. They can be big, they can be small, they can vary in their density, how many individuals there are in a unit area. Populations may experience different climates if they're in different environments, and they could be subjected to different factors. I mean, just think about human populations and how many population centers we have across the United States. We have large population centers in New York City and Seattle, and then in other areas we have very small populations. And we are distributed all across the world, and think of the different climates our populations are subjected to, okay? So populations can grow in size or they can decline. It all depends upon the birth rates and the death rates. Also depends upon immigration and emigration. So leaving one place and going to another is our immigration and emigration. So by studying populations, scientists are able to understand ecological relationships, and it can help them to predict changes in ecosystems and to manage wildlife or even human communities much more effectively. Now, population size refers to the total number of individuals of a species that are living within a specific area. So we might talk about a herd of 150 elephants, let's say, living in a protected reserve. So it might be some type of grassland. So we could have 150 elephants in that area. We could talk about a small pond that might support a population of about 500 frogs if there's abundant food and suitable breeding conditions. And as we mentioned, human populations, right? They can be in small rural towns that have a few hundred residents, or large cities where you could have population sizes in the millions, okay? So keep in mind population size, and then we want to compare that to what we call population density. So density describes the number of individuals of a species that are living within a specific area. And a lot of times it's measured in like square kilometers or square miles, how many there are per square miles or square kilometers. So it helps to show how crowded or how spread out a population is in its habitat. So population size tells us the number. So the size of the population is just the number. So we can say that there's 10 elephants would be our population size. But density gives us a much better picture of what is occurring with that population. So if I said we had 10 elephants, but those 10 elephants are found within 4 square feet, then that's a really different picture than just picturing 10 elephants. You know, you picture 10 elephants, you probably picture them all spread out. But if you try and picture 10 elephants in 4 square feet, then these elephants are like stacked on top of each other, right? Like a circus act. So much different picture when we throw in how much area those individuals are occupying. So high population density can lead to increased competition, especially for resources like food and water and shelter. But if it's low density, it may reduce the competition, but it could also make it harder for individuals to find mates. So there's kind of the good and the bad with each of these. So we can recognize factors that are affected by the density of the population and affect its future growth. And we call these density dependent factors. So imagine a population of deer with access to a fixed amount of food. When the population is small, the amount of food is sufficient to sustain the population. But as the population grows and density increases, the food starts to become a limiting resource. So the deer are kind of competing with each other for that scarce resource. And because of that, some deer may starve, they may be malnourished, they may not be healthy enough to reproduce, and some of them may actually die. So the population numbers will then start to level off, and it's going to level off at what we call the carrying capacity. So we'll get into the carrying capacity in a moment. So density, sorry, lost my train of thought there. So the carrying capacity, though, is the maximum number of individuals that a particular environment can support of that species. Okay, so it's basically the limit for that environment, given its available resources of food, water, space, right? So density dependent factors typically produce what we call kind of a logistic curve, and you'll see that kind of in a moment. And then it levels off. So growth will increase at a certain time, and then it'll level off at the carrying capacity. Now, most density dependent factors are biotic, meaning they're kind of related to living organisms. So a lot of times it's competition for food. It has to do with predation, diseases, because individuals are living so close together, or even pollution from waste material. Okay. Now we mentioned, so here it talks about the number of seeds produced per plant dramatically drops under increasingly crowded conditions. So as your density increases, what's going to happen is you start reaching, once again, that capacity for that particular environment. And so the seeds aren't going to be able to germinate because they're not getting the sunlight or whatever they need to germinate, right? So here's the carrying capacity, right, that we were just mentioning. So it talks about the maximum population size that can be sustained in a given area. So most species, it says, the growth rate of a population decreases as population size nears the carrying capacity. So you can think of it as this is the maximum amount that this environment can carry, it can support. That's the most amount of organisms that it can support with the food, the water, the resources, the shelter, whatever it is that the organisms need. That's the maximum number that the environment can support. So that's the carrying capacity. And this was the graph that I was talking about. So here for the graph, we see over time on the x-axis and population size on our y. And I want you to look at this line that kind of levels off at the blue there. So we see that growth will increase, right? And as we get more individuals and all of those individuals are reproducing, the size of the population is going to skyrocket. But at some point, we see the population leveling off. It kind of flatlines at that point. And that is the carrying capacity. So that is the maximum amount that the environment can support. And so that at that point, individuals start to die or reproductive rates start to decline. Whatever it is, it depends upon what is that density dependent factor that is limiting the population at that point. So density independent factors are typically abiotic factors, such as weather or natural disasters. They reduce the size of the population, but it's not related to the density of the population. So let's say a large population of grasshoppers lives in a desert grassland. During Most years, the grasshoppers reproduce quickly, and there's plenty of plants that are available for them to munch on. But then one year, the area is struck by, let's say, a severe drought. And due to the drought, the plants dry up and they die. There's very low soil moisture, so the grasshopper eggs cannot hatch. So the grasshopper population starts to decline. The population does not reduce in size because it was too dense, but it was because of the impact of the drought, which had nothing to do with the density of the population. All right, so it had to do with the plants dying and the soil moisture. So that was density independent. Here we see in this example here the bald eagle pairs, and it's looking at the eagle population over time. So you can see when DDT was first into effect, the eagle population was very low because it affected the eggshells of the eagles. They were very fragile and they would break, and therefore the young would never survive. And then once DDT was banned, we start to see the population increasing. So this was a density independent factor, this use of DDT. It had nothing to do with the number of eagles that were already present in the population, but it affected the size of the population. Okay. So density dependent and density independent factors both play roles in shaping population size, but they do so in different ways. So density dependent factors are such things as competition and disease and predation. They become stronger. These factors become much stronger a force on the population as the population grows and becomes more dense. So they help to regulate the population around the carrying capacity. But density independent factors like natural disasters and extreme weather affect the population regardless of their density and can cause sudden and, in many cases, unpredictable changes in the population size. But together, these factors interact to determine how populations are going to fluctuate over time and how well